Alright, this video is going to be on how to solve a rational linear equation. Now, I've seen some of you work on some of these problems and some people got stuck, so I want to make a few examples for you to help you out that you can use as you're going through your classwork. Notice on this one, right, it looks confusing because we have the expression x plus 5 being divided, right, that's what that fraction bar line means, by x plus 6. And then it's equal to 8 over 9, a fraction. The first thing you want to do when you get to these, don't panic just because it has this expression in the denominator. I want you to just go ahead and just think about your inverse operations. In other words, really all that's happening is the x plus 5 is being divided by x plus 6. And the opposite operation, or what we call inverse operation of division, is multiplication. So these really aren't too hard. You just need to get rid of the denominators first by multiplying those values to the fraction. Now, I do want to just show you over here to the side a little bit about what I'm talking about. I'm going to write just an easy fraction just to give you an example. Let's say I had 1 over 5, right? So here's a fraction right here. And if I wanted to turn this into a whole number, and I didn't want a fractional value, I could multiply it by its denominator. So the denominator is 5. I'm going to circle it. So I can multiply this fraction by 5. And what happens when I do that, just to show you the math that occurs, multiplying by 5 is the same thing as multiplying by 5 over 1, because we always have an invisible 1 under every integer, or every whole number. And if you multiply straight across, you'd have 1 times 5 gives you 5. And then over here, you'd have 5 times 1, and that gives you 5. And then if you were to divide this out and simplify it, it would just become 1. Now, the reason I showed you all this work is because I want you to notice that all that happened when we multiply by a denominator, all that happens is the numerator becomes our answer. So instead of multiplying all these out, for instance, if you were to, if we're trying to multiply by a denominator, don't do all this work right here. What we like to say is, I like to say they just cancel out. When you're multiplying by a fraction by its denominator, you can just simply cancel them and use the numerator as your answer. So if it's still not making sense to you, let me just go ahead and show you an example with this problem that looks more complex using this idea right here of getting rid of the fractions. So first, I want to get rid of the fractions. The first thing I'm going to get rid of is I'm going to get rid of the fraction on the right side. I see that I'm dividing by 9. So I'm going to circle this 9. I'm going to go ahead and put this fraction on the right times 9. The reason I'm going to do that is because that's going to eliminate my fraction. And all that's going to be left over is the numerator, the 8. I'm going to do this in small steps so you can see exactly what's occurring. So all that's left on the right side right now is 8. I take this value on top and just bring it down. Just like when I multiplied 1 over 5 by 5, it just turned into the numerator of 1. If I multiply 8 over 9 by 9, which matches the denominator, it just becomes 8. So now it looks simpler already. I no longer have a fraction on the right. Now we're going to do the same thing to the left. What looks more difficult about the left is that we have an expression instead of a single number. Before I do, I want to take you back and just have you remember one rule. When you're dealing with equations, whatever you multiply one side by, you have to multiply the other side by. Now on the right, we multiplied 8 over 9 by the denominator of 9 to get rid of the fraction and just turn it into a whole number. So now we got to multiply this left side by 9. So I got to make sure that I don't forget to do that. So I'm going to go ahead and put a dot right here, and I'm going to write a 9 right here. And this just means this is 9 being multiplied to x plus 5. Now when I rewrite this, I'm going to rewrite it like this: 9 parenthesis x plus 5 close parenthesis. The reason I did that is because we have two terms. We have the x and we have the 5. And since we have two terms, we have to make sure that we're multiplying both of those terms by 9. So if I were to just multiply the 9 to the x, it would have been wrong because that's one term. It has to be multiplied to this whole expression in the numerator. Now, I still have this x plus 6 in the denominator. So I'm going to draw my fraction bar and write x plus 6. What I want to do now is I want to get rid of the x plus 6. And I'm going to do the same thing we did on the right to get rid of that 9 in the denominator. So what I'm going to do is I'm going to multiply this whole thing right here, the 9 times x plus 5 times x plus 6. And why it looks kind of scary when you put this up here, because you may be thinking, wow, now this looks even worse. I got to multiply all this out. Well, no, you don't, because x plus 6 is equal to this x plus 6 at the bottom. So these just cancel. They cancel each other out. Now, what we have to do is remember that if we multiply this left side of the equation by x plus 6, we got to multiply the right side of the equation by x plus 6. So to show that, I'm going to put a dot, so times, and then I'm going to put in parentheses x plus 6. And again, I'm doing this in little steps to show everything that's happening. So I'm going to rewrite this nice and clean. The only thing that we have left on the left side over here now is what was in top. No different than when we multiplied 1 over 5 by its denominator. All we had left was what's on top, the numerator. So I'm going to rewrite this as 9 times x plus 5. All that's on top is left over. And then over here on the right, we have 8 times x plus 6. So I'm going to write 8 times x plus 6. Bring down my equal sign. Now, a lot of you looking at this right now probably feel like this is easier to deal with than these rational values we had in the beginning. But now I'm going to go ahead and just follow the process of solving it, right? And it's just a linear equation with variables on both sides, and they have the distributive property. We have those parentheses. So to get rid of those, I'm going to take the number on the outside of the parenthesis and first multiply it to the value, the first term on the inside of the parenthesis. So this would be 9 times x, which would just give me 9x. Then I'll multiply this 9 times 5. So 9 times 5. And remember, if you're not good at doing your multiplication, it's no big deal, right? Use the calculator. So I'll do 9 times 5 so you can see what I'm doing. Notice that gives me 45. So this becomes positive 45. And then I'm going to bring down my equal sign, and I'm going to do that process over here on the right. So I'm going to take this positive 8, and I'm going to multiply it to x. So we have 8 times x, which gives me 8x. And then we have 8 times 6. And I can put that in the calculator, 8 times 6, and it gives me 48. So that's positive 48. Now we have transformed this problem into a simple 8th grade math problem. Next, our goal is we want to go ahead and get our variables on the left. So I'm actually going to change the variables to my black pen's color. And I'm going to move them to the left. And we want the constant values, the numbers that do not have a variable, on the right side. It just makes it easier to solve that way. So let me go ahead and just trace 9x with black, trace 8x with black. And so we're moving on the black values to the left and the pink values to the right. So I'm going to go ahead and draw a little line here, right? That's my equal sign. I'm going to subtract 8x and move it to the left. And 9x plus negative 8x, right? So if you do 9 plus negative 8, it gives you 1. So we're just left with 1x. Now you could put a 1 in front of this x, but I'm not going to put the 1 because there's always an invisible 1 in front of every x. And that's going to be equal to, because these cancel out. Let's see, I got a 48 over here. Now we do need to move this constant value over to the right. So I got to move 45 over to the right. Now that's a positive 45, so I use inverse operations. So I'm going to subtract 45. And then I'm going to subtract 45 from this side. All right, and so I have 48 plus negative 45. And I always treat it as if I'm just adding everything together. If it's a negative value that I'm combining with it, I'm simply adding a negative number. And when I add a negative number, when I put negative in the calculator, I'm hitting this negative button under the 3. So notice that leaves me with positive 3. So this becomes positive 3. And that's our final answer. X is equal to positive 3.